presentation of the DALI lighting control method and introducing the next generation of lighting control, DALI MultiMaster. In this presentation, the listed topics will be discussed. This presentation shows that the Philips Dynalite lighting control solution can be used in both existing and new projects. By being a flexible control system solution over the entire project that delivers occupancy comfort and achieving real energy savings to the owner. Philips Dynalite has been successful in developing lighting control systems for 20 years. The continuing dedication to improvement and development of the lighting control system has led to many successful generations of products. All products have been designed and built for the unique requirements of the lighting control market, creating a dedicated range of load controllers, user interfaces, integration devices and software packages. These individual products can be brought together, creating a system solution for meeting the expectation of any project. As the Philips Dynalite system is built up out of individual components, the solutions are indefinitely scalable. Regardless of the project being the size of a single tenancy, a whole floor, or the entire building, a Philips Dynalite system can be built to meet the function needs and customers' budget requirements. Different combinations of products can be brought together to meet different project expectations. Whether the project is a shopping plaza, hotel or an office, Philips Dynalite has a solution that will meet the end user's needs while being as cost-effective as possible. Creating a lighting control system requires the following of steps, making sure that the right components are selected. First step requires knowing what style of light fittings are used so the correct type of load controller can be used. Load controllers. The muscles of the system that perform all the lighting load requirements. These devices coordinate the various lighting groups together so that there's a balance between occupancy comfort and energy savings. A large range of load controllers is available to meet the requirements of the many different lamp types available in the market, the number of channel for the project requirement, and channel capacity for simpler installations. User interfaces, allowing end users to interact with the lighting control system. Occupants of an area can use one of the lighting control panels, putting the system into a different mode. Passively, motion sensors can be used to detect if an area is occupied while measuring the naturally available light. By combining this information together, the system can select the right level of artificial light automatically that will be comfortable for the occupant while being as energy efficient as possible. Integration devices allows for third-party systems to seamlessly integrate together. This can reduce the amount of times an end user needs to interact with the different systems in an area. For example, if the air conditioning and lighting control are integrated together, then the lighting control sensor can be used for both systems, reducing the number of user interface devices required. Software allows for end users to control their personal lighting from their very own PC, and there are opportunities to use a worker's PC for occupancy detection. Dynalite. All these components are interconnected with the Philips Dynalite dedicated communication protocol, Dynalite. With powerful command functions that allow for site-wide changes from a single network message, this purpose-built protocol can rise to the challenge of a project's needs. Dynalite. All these components are interconnected with the Philips Dynalite dedicated communication protocol, Dynalite. With powerful command functions that allow for site-wide changes from a single network message, this purpose-built protocol can rise to the challenge of a project's needs. Each component of the system comes together to create the system solution. Used like building blocks, the individual components work together to become part of a living system. What is a DALI lighting control system? To practically explain how a DALI lighting control system can be applied, this floor plan will be used as an example. In any office floor plan, different areas are required, such as single office, open office areas, perimeter areas and reception. DALI defines a network of lamps and controller as a universe. In a DALI universe, all light fittings within a project are connected together on the same network. The DALI system assigns each light fitting a unique network address, which allows a lighting control system a method of sending instructions to individual light fittings, adjusting them to different levels if required. Within the DALI system is a method of grouping multiple light fittings into useful logical areas. In the example, multiple fittings can be arranged into logical groups that match the physical office layout. Now, the different types of areas that are required within the office space can perform specific functions for better energy management performance. The perimeter zone, shown in light blue, can be using a daylight harvesting method of control. Open office areas or single office can be performing presence detection. This allows for the end users to better manage their own project. The presentation will use this example as a reference for different control methods. The DALI specification is managed by a group called DALI AG. This is a collection of multiple manufacturers of lighting ballast and lighting control systems. These companies have come together to create a communication protocol that can be used by all. It is common across all manufacturers. No single manufacturer owns the DALI protocol. DALI stands for Digital Addressable Lighting Interface, making DALI a dedicated lighting control protocol. The DALI protocol is made up of various IEC standards. More information on the DALI protocol is available from the DALI AG website, shown here. As DALI is a communication protocol, there are some addressing limitations within the system. These limitations are common within all DALI systems and should never be exceeded. A DALI universe cannot have more than 64 DALI addressable devices. The 64 light fittings on a single DALI universe can be divided up into 16 logical groups. This allows for the lighting to be coordinated together. Within each of the 16 lighting groups, 16 lighting scenes can be recalled. The physical DALI network requires a 2-core cable. It must always be remembered that the DALI network only has functional isolation between the active power and the DALI network. It is essential to remember that the DALI network should always be considered as live for safety. This is quite a slow protocol in comparison to others used by computer networks. But as it is an event-based protocol dedicated for lighting control, that is not required to transmit large amounts of data, it is more than sufficient. The DALI network has a maximum supply of 250 millilamps. This is quite essential that this is never exceeded, and why we cannot have multiple DALI power supplies on the network. The DALI system requires 2 wires additional to the mains power as a transport layer, so running parallel to the mains power cables into the fittings will be an additional 2 wires of cable. These additional wires carry the DALI protocol. DALI is not polarity dependent, so the 2 wires can actually be wired either way, positive-negative to negative-positive. There is a requirement for the gauge size of the cable depending on the length of run. DALI cannot be run more than 300 metres in one particular universe. If more than 300 metres are required, it is recommended that a DALI network repeater be used. DALI ballasts consume power even when the lamp is turned off. This is what is referred to as the standby current consumption. When the lighting control system has instructed the ballast to turn its lamp off, it will be in standby mode, waiting for a signal to turn the lamp back on. The DALI ballasts will continue to consume this standby power consumption power even when the lights are off. This consumption never stops, 24 hours a day, 365 days a year. Currently, within the market of DALI lighting control, there are 2 traditionally types of using DALI within projects. We'll be introducing a new method called DALI MultiMaster. The simplest method of control is DALI Broadcast. This method works very similar to other known protocols such as DSI and 1 to 10 volts. Each required lighting group is to be individually required back to the load controller. We can see on the example here 3 lighting groups, and they've all been wired individually back to a load controller. A sensor is monitoring each of these areas, and they are connected back to the load controller using the traditional Dynalite network. The 3 areas in the example may be a single office, an open office or meeting rooms, and during the commissioning process the sensors will be logically assigned to each of those groups, and the controller will be able to respond to the messages from the sensors. The DALI addressing system connects all the ballasts together onto the same network. This allows for only one cable to run to the distribution board. The advantage of this method is that the cabling requirements of a project have been drastically reduced, as 16 different lighting groups can be connected together. This method of installation is much simpler for electrical contractors to apply, requiring less cable and less termination points. This can make the whole lighting control system much cheaper. The motion sensors are connected to a Dynalite cable in the same way as a DALI broadcast. 4th animation. During the commissioning process of the lighting control system, the individual ballast addresses must be discovered. This is what's referred to as DALI enumeration. These are the number in black that are appearing now. The individual addresses of the ballast are physically located and entered into the lighting. Once all this information about the individual ballast addresses has been collected, then the fittings can then be grouped into these useful areas. These logical areas are overlaid on the original DALI addresses, and we can see here that they achieve this exact same grouping effect of what was achieved in the DALI broadcast method. Functionally, from the end user's perspective, there is no difference in what control is provided. The advantages are that it's been easier and cheaper to install. Any future changes to the required lighting groups are possible simply by reassigning the logical ballast areas. No physical change to the lighting wiring is required. 6th animation. In the DALI MultiMaster system, the Dynalite network has been completely removed. The sensors are directly connected onto the DALI network already used for lighting. This allows for the lighting control system to have the same network control of the sensors by utilising the existing DALI network. The DALI MultiMaster sensors are completely powered from the DALI network, removing any need for additional power cabling. Same as before, the individual DALI addresses information of the ballast needs to be discovered. This is the same enumeration process that is performed in traditional DALI addressing system. Once the individual ballast addresses have been found, the lighting control system also uses the same process to discover the sensor's unique addresses. The sensor addresses are different than the traditional DALI ballast addresses, and they don't use the same 64 reserved addresses ballast. This way, the sensors do not take away from the maximum 64 ballast that can be used. As before with the DALI addressing system, a commissioning technician will find the individual DALI address fittings and then group the fittings into logical areas. Once those areas have been defined, the sensors will also be assigned to those areas. The sensors and the ballast have all been allocated a logical address and logical area. The system is now complete. This has all been achieved using the one network. There is no need for parallel networks to be wired to achieve the same function. It is important to understand how the many different elements come together to create a solution for a project. The office floor plan shown before will be used again as an example to show the differences between DALI broadcasting, DALI addressing and DALI MultiMaster. showing how the three different systems and how they applied to the same floor plan. This is so you can see the wiring requirements of each of these systems and why the DALI MultiMaster is such an advantage. This is the DALI broadcast system applied to the office floor layout example. Each of the lighting groups in the individual areas need to be wired back to the load controller separately. This is also the Dynet cable shown in orange, which needs to be wired to each of the Dynet sensors. Each sensor issues instructions back to the load controller via the Dynet network. Load controllers will respond to sensor requests back to the ballast connected to it. This system requires a total of 8 different cable runs to achieve the required functions of this area. DALI addressing connects each of the ballasts together into the same network. The DALI system allows for each group of lights to be controlled separately. The sensors still require their own network to communicate area status information to the load controller. This system still requires 2 networks to be run. These networks are often running in parallel with each other. DALI MultiMaster connects all the ballast and sensors to the same network. This system utilises the existing DALI cable for all the lighting network devices to communicate to the load controller. Sensors will detect activity within their area and report that back to the load controller. The load controller will then decipher the message and perform the appropriate action. If required, instructions could be sent to the ballasts on the same DALI universe and a network message sent on the Dynet network for other devices to respond to. To complete this solution, the install contractor will only need to run 1 network cable. A summary of the installation requirements of the 3 different DALI systems. The advantages of DALI broadcasts over the other methods are reduces complexities by only using 1 communication protocol for all ballast and user interfaces devices in the field, which reduces cable requirements of an installation by 50%. Philips Dynalite offers all 3 DALI solutions from 3 different controllers. A DALI broadcasting solution is achieved with the DDBC 1200 load controller. Supporting 12 output channels allows the unit to control 12 lighting groups. The control outputs can also be independently configured for 1 to 10 volt control and DSI control. For a DALI addressing solution, the DDBC 320 DALI load controller is available. This unit is capable of coordinating 3 DALI universes, allowing it to drive 192 DALI individual addresses. The unit has built-in DALI power supply and built-in power replays for each universe that removes lamp standby power consumption. Philips Dynalite is now introducing a 3rd DALI solution called MultiMaster. The DDBC 120 DALI load controller support full DALI addressing of individual light fittings and can also coordinate the inputs from Dynalite DALI user interfaces such as sensors and dry contact inputs. These are the 3 products that make up the DALI MultiMaster system solution: the DDBC 120 DALI gateway, the DUS 804C DALI multifunction sensor, and the DPMI 940 DALI dry contact input. We'll now detail how each of these devices can come together to form system solutions for any project. The DDBC 120 DALI gateway controller is capable of driving a full DALI universe of 64 fittings. The unit is mains powered and requires no external devices for DALI communication. This unit supports user interfaces connected directly to the DALI network, allowing for sensors and dry contact inputs to use the same communication as DALI light fittings. A max of 10 user interfaces can be connected to the load controller. The unit supports Dynet communication into the Dynalite system, allowing reconfiguration from the standard commissioning software and being part of a system solution. The device has an internal 20 amp power relay that can be used for removing standby power consumption of lamp fittings that have been turned off but still consuming power. Here is a single-line example of how the DDBC 120 DALI can be wired. At the top left-hand side, the active supplies to the device. The unit requires a mains supply at 0.25 of an amp to power the internal electronics. There is an option of a second supply to a 20 amp power relay. This relay is used to remove the standby current consumption of the light fittings. The unit will automatically open the relay when all of the lamps within its universe have been dimmed to 0%. The DALI output is wired directly to the DALI fittings and DALI-compatible user interfaces. There is no need for an external DALI power supply or DALI transmitter, as they are built into the device. The Dynalite network is connected directly to the device, making it part of any Philips Dynalite system. The devices are fully configurable from the Dynalite port. This allows for the device to be commissioned and reconfigured when required on site without the need for a commissioning technician to connect directly to the unit. A wiring example of how the unit can be connected to circuit protection devices. From the supply, the device is protected from a 20 amp magnetic circuit breaker. This provides protection overloading on the supply side. As light fittings have an inherent earth leakage current, residual current detection devices have been mounted downstream from the device. Multiple RCDs have been used, which allows for the project to take full advantage of the 20 amp capacity of the internal power relay. The DPMI 940 DALI is a 4 dry contact input device that is fully DALI network compatible. It does not require an external power supply and connects directly to the DALI network. The unit is completely software configurable. It has no requirements for manual trim, POTS or DIP switches. The only input into the device is the service switch used during commissioning. Pressing of this service switch allows for the commissioning technicians to locate the device's address. Each of the dry contact inputs has an option of functions from present recall, ramping, toggling on and off, or to start a task. The device is traditionally seen in a wall panel application picking up bell presses or button presses. From these button presses, it's able to perform any one of these functions. Instructions sent from this device can be used to affect lighting in its own DALI universe, multiple DALI universe or other Philips Dynalite load controllers. The device can also be used in applications for when there is a removable wall and two areas needed to be logically joined together so that they perform as one. The small size of the device allows it to be mounted in most wall boxes. The DUS804C DALI uses the DALI protocol for power and communication to the load controller. This allows for the sensor to control DALI fittings in its own universe, multiple universes, or any other Philips Dynalite control channel. No extra components are required for its operation. The DUS804C DALI is a multifunction sensor, able to perform both daylight harvesting and PIR motion detection at the same time. This allows the sensor to automatically start a daylight harvesting strategy once motion is detected. The sensor is fully networkable and does not require any manual adjustments. All settings are completely configurable by the commissioning or head-end software. This allows the sensor to have multiple configurations throughout a 24-hour work cycle. During trading hours, the sensors can be configured from a network message to have a timeout of 30 minutes, so not to disrupt occupants from their tasks. Then, during after hours, a DALI network message to the sensor can reconfigure its timeout to only 5 minutes, having a more aggressive energy management purpose. Here we see how all the DALI devices are connected together in the field on the same wiring. A DALI ballast requires an active, neutral and earth for power. Running in parallel will also be the DALI figure 8 pair shown in black. DALI emergency fittings will have an additional permanent active, so the fitting is able to detect a loss in power and still be controlled. All Philips Dynalite DALI controllers are compatible with emergency fitting and with head-end software, able to perform battery test and lamp tests and reports. These reports can be stored and printed off as required. The DALI emergency fittings and the DALI ballast both consume DALI addresses. A total of 64 of these devices can be put onto a single network. Some DALI emergency fittings consume 2 addresses, and is highly recommendable that you investigate its requirements. It's also recommended that a DALI universe is not loaded to its full 64 capacity. Some spare capacity should always be left within a DALI network. I recommend that you never populate a DALI universe more than 45 to 50 ballasts. This allows for additional ballasts to be installed after the project has been complete. It is very simple to install additional ballast or 2 into a network that has not used all DALI addresses. It is very difficult to run an additional DALI networks in a completed network. The user interface devices, contact devices, are connected directly onto the DALI network, like all the other devices, and do not require any additional network cabling to function. The user interface devices do not consume any of the traditional DALI 64 addresses, as they have a different method of addressing. There can only be 10 user interface DALI addresses on a single network. By using DALI MultiMaster, a project can effectively cut the network cabling requirements by half. I think that's what it's meant to say, Dave. By using DALI MultiMaster, a project can effectively cut the network cabling requirements by half. Here, an entire lighting control system is shown. Multiple levels of a project are networked together to form a single network. The DALI MultiMaster devices are one of the solutions amongst many that Philips Dynalite has to offer. By using the DALI MultiMaster in conjunction with other load controllers, user interface and integration devices, a scalable solution can be created for performing switching fusions, LED dimming, DMX transmission, ultrasonic sensors, multiple control panels, integration to third-party system, computer head-end systems, and BMS integration. By having the DALI MultiMaster system within the Dynet network, we can receive messages from a DALI sensor and have that transmitted to any other device on the network. For example, the DUS804C DALI sensor may need to instruct another controller, such as a relay or LED dimmer, that has detected presence within an area. This is possible with the Dynet network, so multiple devices are able to respond to the DALI messages. Other network devices, such as an ultrasonic sensor, user control panel, or even a timer clock, can send out a message to the Dynet network, and the DBC120 DALI will respond to the message appropriately. Applying a control solution into a real project example can be challenging if the lighting control does not allow for the coordination of multiple DALI universe together. Very rarely, one DALI universe will fill the needs of an entire floor. Typically, multiple DALI universes need to be used in conjunction to cover the full scope of a project. Here, the 2 separate DALI networks using the DALI MultiMaster sensors have been installed. The installing contractor is often not fully aware of the floor's final configuration. To make the installation as simple as possible, the contractor will wire up all the DALI fittings and the DALI sensors to a grid pattern. This has left a physical gap between the 2 DALI universes. As the end user has taken occupation of the floor, the logical areas required have actually crossed the physical boundaries of the DALI network. To overcome these issues, the MultiMaster system can depend on the Dynet system. As the DBC120 DALI controllers are mounted and wired together using Dynet, the physical boundaries between the 2 DALI universes can be overcome, creating one seamless system. When the DUS804C DALI sensor picks up motion within an area of the office, it will transmit a message back to the DALI load controller, which will then transmit the message back to Dynet. This message will be picked up by the adjacent load controller and will perform the appropriate action. so that the two lighting groups that you see here, which have crossed the physical DALI boundary, are operating as one. This allows for the entire Dynalite system to be indefinitely scalable, whether we need it to be one room, a tenancy, a floor, or an entire building. By using the Dynet system to communicate between the various Dynalite devices, practically any required function can be achieved. Over time, a project requirements change and areas need to be rezoned. To adjust the lighting zones when required, typically would require a professional commissioning technician or a qualified person to manually adjust the areas. With the use of the Philips Dynalite head-in software map view, a facility manager is able to re-coordinate the zones to suit. Adjust the use of the Philips Dynalite head-in software map view, a facility manager is able to re-coordinate the zones to suit. Using the software, a facility manager may simply delete a work zone, then regroup the lights as they see fit. They may regroup the lights across multiple DALI universes across multiple networks. The head-end software will be able to automatically reconfigure the various different load controls and user interface devices to accommodate the new lighting zones. The Philips Dynalite system will be able to configure the logical areas across the multiple DALI universes as required by the end user. The sensors will also automatically be reconfigured. The entire system can be remapped by the use of a few mouse clicks without any in-depth knowledge of its internal workings or the physical wiring of a particular floor. So in conclusion, we can see that the Philips Dynalite DALI MultiMaster solution has reduced network cabling by 50%. The solution provides a flexible and unlimited scalability from a single tenant to an entire building while maintaining the advantages of a DALI system. The DALI MultiMaster gateway controller is fully compatible with all other Philips Dynalite devices, allowing all other solutions, integrations, user faces and load controllers available for various other solutions as required. Built into the DALI controller is a 20A power replay capable of removing the standby current consumption when all the lamps have been switched to off. Fewer network cabling and fewer cable terminations make for a simpler system to install, reducing not only in cable costs but in labour costs, producing a faster payback. Sensors are multifunctional and capable of performing both PIR and daylight harvesting capabilities. At the same time, they communicate directly onto the DALI universe, which can then be translated onto the Dynet network, making the sensors capable of controlling any other Dynalite device on the system. All user interfaces are now fully networked onto the DALI system, allowing them to be configured by the head-end software, and are able to be manipulated by timer-based events, giving them different features and functions as required through the 24-hour cycle of an office space. Philips Dynalite DALI solution also supports DALI emergency and DALI reporting. This also allows for the system to interrogate each of the ballasts to find out whether its lamp has failed and if the ballast has failed. From this information, a report can be generated through the Envision software to the facility manager of what actions need to be taken. Philips Dynalite supports full regrouping of the What actions need to be taken? Philips Dynalite supports full regrouping of the data universes through the head-end software. No additional cabling or network adjustment is required to the DALI controller as the system is completely configured through the Dynet network. The software package is The software package is completely graphical-based, allowing for easy use. A facility manager will be able to see the floor plan and where all the lamps are. There is no requirement for a working knowledge of the Dynalite system or how it has wired, as the software will manage all required settings. That's the Philips Dynalite DALI solution. Thank you for your attention.